Okay, let's get started. Welcome everyone to today's CNCF webinar, ARM Developer Experience Spanning Cloud, 5G, and IoT. I'm Jerry Fallon and I'll be moderating today's webinar. We would like to welcome our presenters today, Darragh, co-founder of 56 Cloud, and Marc Meunier, Senior Manager of Ecosystem Development at ARM. Just a few quick housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Please be respectful of your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinar page at cncf.io/webinars. With that, I'll hand it over to our presenters to kick off today's presentation.
Thanks for the introduction, Jerry. And hello, everyone. My name is Marc Meunier, and I'm part of the ecosystem development team that is part of the larger infrastructure team at ARM. We focus our attention on leading projects that advance technology in the wide landscape that spans from cloud to the edge, and it includes 5G and rich IoT. I'm happy to be here today to talk to you about the active programs with our ARM partners and that help the developer community in general. With me presenting today is a good friend of mine, Darragh Grealish, and also an ARM innovator.
Cool. Hey, thanks. Thanks, Marc, for the introduction there. Hi, I'm Darragh Grealish. I'm co-founder of 56K Cloud, and as Marc said, I'm also recently joined the ARM Innovator program because I'm one of those guys who's not afraid of hardware, let's say, and connecting it to the internet. I work at a company where we are, excited about developer experience across all these CNCF projects, and that's why we, really like to be working very, very close to ARM and the CNCF community, especially on, using these technologies across a wide variety of projects we work on and the community. I come from formerly a networking background, but most recently been working on a lot of cloud infrastructure, and I come from an embedded systems education as well. Cool. So Marc, I hand it over to you.
Sorry, didn't mean to cut you off there with the slides changing on you. All right, good stuff. So what we're going to cover today in the talk, we're going to start with just a short introduction of who is ARM. We'll look at programs that we run to support the developers, activity in the software ecosystem. We'll then take a deeper look at Parsec, the latest project that we donated to the CNCF. Darragh will walk us through a case study where he will share his learnings and highlight best practices. And then we'll wrap it up with some key takeaways. All right, so who is ARM and what do we do? And I'm sure there's all kinds of people on the call. Some might not know. ARM creates technology intellectual property, so building blocks that are then licensed out to semiconductor partners. So we don't create chips ourselves. We create IP, we provide it to our partners like NXP, Qualcomm, Samsung, and AWS, and then they create the silicon. So in the past, ARM was present mainly in embedded devices and in mobile devices, but over the years, the landscape has grown tremendously, and it's continuing to grow faster than ever before. Today, ARM IP can be found in devices from embedded and mobile, laptops, tablets, and more recently in data center and the cloud with AWS instances. We're very proud of the fact that today the largest and fastest computer in the world is based on ARM IP. So just showing the transformation and the growth that's been taking place over the years. Now, what's interesting is as a developer, it's inevitable you'll see deployments on ARM IP. Now, the interesting thing though is you might not necessarily notice that you're running your software on a different hardware platform. And that's because of the beauty of layering, which allows you to build more complex applications on top of abstraction layers, which enables application to run on a diverse set of hardware. This is beautiful because it allows freedom for the developer to concentrate on the problem at hand, while DevOps can manage deployments independently with freedom of choice when picking the hardware. So the team that I work with at ARM is dedicated at making the developer environment effective and efficient. Because as we know, the products are only as good as the software that's running on them. And with compute moving closer and closer to the IoT devices, there's a lot more need for this this setup. All of this work that we're doing, the framework needs to scale to overcome all these new challenges. So how do we support our ecosystem of developers? Well, ARM has a structured developer program with the primary goal of enabling frictionless development and deployment of cloud-native applications on the ARM architecture from edge to cloud. So we accomplish this goal by providing technical guidance and resources for infrastructure solutions. And we target developers of all experience levels, so you don't need to worry if you're just starting out. There's lots of collateral out there to help you out. We also have a unified forum where developers, partners, and ARM experts can discuss various topics. We bring together silicon partners, white box manufacturers, and developers to create infrastructure solutions that scale. And the outcome is often a mix of turnkey solutions and development frameworks. Now, the most important part of this program is the developer community itself. And ARM provides the structure and the landing space, and then participates alongside the community of talented designers. So come check out the website, come check out our developer content, and hopefully it can help you out with your next project. Now, to recognize some of our most innovative developers and provide a platform for sharing their work, we created the Innovator Program. Here we support the innovators as they evangelize development practices and share their experience for the benefit of the developer community. And you can connect with the ARM innovators at the Innovation Coffee, the live stream. Also, you can come check them out on the community Discord server over here. This collaborative presentation itself is an example of ARM working with our innovator, Darragh, to showcase his great work. Now, ARM has been present at the CNCF for some time now. And back in November 2019, if I'm not mistaken, we updated our membership to the platinum level, so the highest level for the CNCF. This aligns with our commitment to the developer community. We see cloud native development stretching closer and closer to the embedded developers. With the proliferation of interconnected devices at the edge and the deployment of 5G, it's paramount to structure your application such that it can be managed remotely and securely. And the cloud native best practices will help you with that journey. So building on frameworks that lay a foundation accelerates wide-scale deployments that are necessary when you're connecting a trillion devices. So we're active in a number of OSS projects as well, right? So we mentioned the CNCF, we're part of the Confidential Computing Consortium as well. We're engaged in projects like SPDK, DPDK, Yocto, and Parsec, as well as LF networking and LF Edge. So if you need some help, come find us when you're developing your next project, and we'll be happy to help you out. Now, let's talk a little bit more about a very relevant project to today's talk, which we have recently donated to the CNCF with our partners. Parsec started back in 2018 during discussions between ARM and Docker. And it was focused around how to bring security to application developers in a diverse, heterogeneous edge environment. At the time, I actually worked at Docker in Strategic Alliance and sat at the other side of the table, wondering about the impact of scaling deployment with Docker containers in an edge space. At the time, we identified two fundamental challenges. The first one was, how do we leverage hardware-backed security on a diverse set of hardware without being locked in? So the engineering team highlighted the diverse set of security primitives present in the edge ecosystem as a major challenge for cloud-native development. With simple operations like signing payloads or providing keys, these needed to be implemented in different ways on different devices, which really slowed down development. So at the time, the engineering team knew they needed to come up with a layered architecture that would abstract all these dependencies from vendor-specific security. The second challenge that was identified was, how do we enable a secure multi-tenant environment when the hardware key management systems don't support multi-tenancy? So imagine like multiple applications from various banks running on an end device. You want to keep all these applications separated. You want to make sure that their security connections are independent and can be viewed by the neighbor next to you. So this kickstarted discussions. And after many months of collaboration, we came up with, well, actually we changed the name quite a few times as well. But we kicked off the Parsec framework development. So Parsec stands for Platform Abstraction for Security. It's a framework that defines a universal software standard to handle secure object storage and cryptography services. It's not limited to ARM chipsets. Instead, it's extensible and designed to accommodate use cases on many hardware. So let's take a closer look at what that looks like in terms of the Parsec architecture. So Parsec is built with a layered architecture and provides first a library that's normally, well, would be used in a language that you're developing in, providing a simple set of APIs to the developer. The library then communicates with the Parsec service over a standard wire protocol. And then the Parsec service uses the providers to connect to the secure backend that's available in a device that you're running on. So Parsec is expanding to cover all kinds of use cases. The framework is maturing and the code required to enable use cases is growing. And we really wanted this to grow in a governed environment where it really felt like it was community-led with the developers, open governance. And this is the reason why we decided to donate the project to the CNCF. So, for example, of some of the work that we're doing these days with Parsec, we're working heavily with Red Hat, and in fact, this week we're going to record demos that are going to be shared during ARM Dev Summit, where Parsec is going to be showcased on Fedora IoT, and we're going to demonstrate some use cases on different hardware and show how it simplifies security. And if everything goes well, we're going to try to include Parsec into the Fedora 33 release that's slated for the end of October. So exciting news for Parsec. We're also working with Spiffy and specifically the Spire implementation to showcase how Parsec works with an ID provider for multi-tenancy use cases. And we're hoping to showcase that by the end of the year. So please go check out Parsec and see if it's right for you. Come and join us during our bi-weekly sessions with the community. And yeah, come take a look at it. See if it makes sense for you to leverage this. So imagine an environment now where applications are developed and then deployed anywhere on the map, from IoT to edge to cloud. Depending on latency requirements or bandwidth or reliability requirements, a single application might make sense to run in the cloud under one circumstance, while in another situation, it might be better suited to run at the edge or again in an IoT device. So no longer bound to a homogeneous architecture and offering new services that were not possible just a year ago. Having the ability to move the applications freely and still maintaining the security requirements is a powerful statement. In the next part of this talk, Darragh will walk through a case study looking at the various tools we talked about and showcase how this can accelerate deployments.
Hey, cool. Thanks, thanks, Mark. So let's see if yes. So yeah, thanks. I mean, to get into the details and how that use case would actually be used in the real world, and how, let's say, me as a developer can consume Parsec. I don't need to understand the ins and outs of Parsec. It should be that me as a developer, I can say I have certain security requirements I need to address. I have to develop an application across the edge, an IoT device, and the cloud. So given that use case, you know, how do I develop towards some sort of heterogeneous and application that doesn't require a specific programming interface, you know, per platform that I will be using on. So you can think about, you know, I could be working across multiple architectures. I could have, you know, multiple types of hardware over a span of time where they need to address a specific, you know, common application need. But at the same time, you know, how do we reduce that developer burden? And so this is where, you know, the whole objective is to really, you know, have the secure edge compute. And if you, with the whole objective of, you know, reducing that, you know, bar to energy developers, you're going to make it easier for developers to develop, you know, secure applications. It's not going to be where, you know, we resort to the checkbox security thing. We're not going to be too concerned about physical security to the device, because the idea is that we can actually build those security requirements into the framework and into some sort of reference implementation. So really to you know, onboard developers quicker, allow security to be seen as an enabler, and also other security primitives to be brought into this abstracted framework, as Mark mentioned. So things like maybe cloud HSM, using HSM remotely. You know, as those edge devices become more mature, and I'm just going to look at it here. Can I go to the next slide? Yeah. So take, for example, the whole hype around 5G, and the objective of, you know, secure on a 5G application. And security is a huge topic again in mobile technologies, particularly again with, you know, with the 5G coming down the road. And it doesn't mean that the security can't be implemented in 4G, of course. I mean, a lot of the features of 5G is essentially going to be backported into those networks. But given the example, for example, if I'm using here an IoT kind of AI device, which is recently being released by 96Boards, another good partner of ARM, that would have a certain security primitive available to me. I might already have a cloud application that is running, you know, in AWS, for example. I'm probably used to using the cloud HSM, but you know, me as a backend developer in this context, you know, the question is how do I enable, you know, all the platforms down the line until I get to the application on the person's hand, that consistency of security. And so, for example, in the cloud, you might have storage requirements, secure storage security requirements. There, you know, your application can consume Parsec, for example, but I don't have to code directly to the HSM. It could be a containerized workload that gets pushed out to the edge based on the, you know, on the advancements of the, you know, edge IoT and more compute capacity that comes on the edge. I might manufacture something once and then still bring more features as they go on. We all know the Tesla use case where the Tesla essentially increases in value the longer you have it, because they can deliver continuously more features on top of that, you know, software platform on wheels in a sense. And so how do we enable these? And this is where we see, there's going to be this full stack kind of 5G developer, edge developer, where he or she will need to develop across these, 3 platforms, and handle or deal with the whole idea that there may be, partial connectivity issues. They want to reduce the challenge of having to implement, again, like Marc mentioned, across various different vendors, their kind of security solutions. And so let's take a look at that, and take a look at what would that use case imply. Yeah, and how do we enable those embedded developers? Well, I think here it is. Okay, so what I'm going to walk you through is, given a scenario where I have to build an application which is an IoT sensor, it has a certain edge context to it, and it also needs to talk to some compute in the backend. Your application might have a set of requirements that you have to deliver on. These requirements may be, anything from quite abstract to quite, hardcore in a sense. If those requirements are always changing, you need a framework that allows you to give that flexibility of that change, because you might not know the hardware target platform that you might be running on, and you may have a requirement that to run across a lot of devices, like thinking about containers on the edge, for example. So me as a developer would use the Parsec client as a way to implement that security and those features that are allowed underneath those security primitives. And it might be that I'm handling user data or data stored in an encrypted platform. I want to meet maybe some PCA requirements, but I only need to use the Parsec client library once in my application. And then this allows me to meet that diverse set of requirements. So what we're going to do is take a look at just the example that's on Rust, and this is available in the Parsec community. It uses the wire protocol as an example. So what I'll be able to show you is how linking those blocks between Marc showing the service in the back end, me running a simple Rust application just to ping that service to connect to that backend service. But there's nothing there that is dedicated directly to the actual underlying security provider. So this is an example that I want to walk you through. So what I've done is essentially in my cargo YAML file actually added Parsec client as a dependency. And of course, it's quite a fresh project, so working on testing. And if you take the Rust example on the web, and you can actually just copy and paste this code in and get started. It's not too complicated. And so what we have here is pretty basic hello world application. What we're doing here is we're consuming the Parsec client, asking for authorization. There's a basic client implementation, and then we're just going to have the features of security read in and out. So what happens is further down, I instantiate the application, I load in the auth data, and because this application is running in user space, and that user is actually already added to the Parsec client network, it will be able to discover the Parsec service through that ability. So let me just walk you through this. I'm going to share my screen. So let me just share my screen now for a moment. And we'll definitely be able to take questions in the end. So just think of any questions you want to ask while I look for this magic window. Here we go. Share. All right. Oh, I showed the demo already. Anyways, back to what it looks like. Nope. So what I have here, let me show you the service running in the background. So below here is in a different user space is Parsec running, and this is the just taken from the normal GitHub Parsec website. It's quite easy, simple enough to follow the installation instructions. Essentially, what I have here is I have a user running on my computer here. He or she's part of the Parsec clients, and it's it has a socket to communicate between each other. Parsec socket. So this is how it's working on the same host. What I've done is essentially compiled it locally. I'm going to run into debug so you can see some features coming out. And what I'm doing is I'm using the embed crypto provider. This just gives me flexibility that if I don't have a hardware-based crypto provider on my platform or my laptop I'm working with here, I can load in the crypto provider for this purpose. So what we see is service loads up, check some simple creating the embed crypto provider. And what we'll do now is we'll go up to our example and have a look at what's happening up here. So let's get the main RS. So as you saw on the slide there, we're just learning, loading in some standard out stuff from the Rust client. So this is taken from the example from the Rust. If you want to learn Rust, go to the Rust website and you can see this example. What I do is inserted the Parsec client for authentication, the basic client, and to do some secrets. Essentially just printing out how is everyone doing as a sanity check. But if you look at here where my application I started, I actually asked for authentication, saying that I want to start a new secret. The client then instantiates, and then I asked to ping that client. Then to check that we have our wire protocol up and we can talk to the service, what I do is I do a simple check and hope the demo gods is with us today in talking with this service. But you can also go further down and you can also list providers. So let's have a look. We run this. So just to sanity check, I'm also running here as a Parsec client. So I also have permission. I just need read permission on the socket just to watch it. So there you go. See also the socket. There's a sanity check. So let's just do Kaggle run, and that's it. What we've done is compile the program. So I've compiled this before, and I've got all the packages down from create, and there we go. We can see we're talking to the Parsec service. Just to prove that that's working, let's kill the service. Let's try again, and we should fail. So panic, ping. It couldn't execute the ping, so it's refused connection. Just to be sure. If I changed also the permissions, on that folder, then it also probably, shouldn't work. But let's start it up again and run a battery of tests. So what I'm going to do is run tests across it as well, and we'll get back to our presentation with good. Here I am again in the user as a service. The end-to-end tests. And this should run a battery test. So now we have, so there's one failed. Yes, exactly. We have 8 passed. Now that is a good way to understand what's possible with Parsec and to see what features are available right now and what you could start working on. There's a good set of features. There's it's not rocket science to try out some of these. So signing keys, encrypting keys, verifying decrypt intent. So actually using all those kind of internal components in Parsec, and then what you can do is swap out providers and see what is possible. There's an interesting one, for example, create OEAP, and of course, I mean, it's still in development, but exciting project to try. So yeah, let's get back to the presentation. So Marc, I don't know if you want to share your.
Yep, sounds good. I'll take it away here. That should work.
Yeah, so the key takeaways here, what we're looking at is, again, I mean, it's trying to really get security in the OSS developments and frameworks. I mean, and try to have a, an agreement or tools to enable that, everyone can be concerned about security. They don't have to be security experts. They can essentially consume, frameworks like Parsec, and then allow, hardware platforms to change underneath, not having to know all those internals, directly, but to really start with some sort of, reference design. And that's kind of also kind of what I'm trying to showcase inside the ARM Innovator Program is really these best practices in reference design, keeping it simple first, and also to showcase, how Parsec can really enable those, edge chipsets. But feel free to check it out. There's the Parsec GitHub page. There's also a book on it. that also explains a lot, and also a lot of the backgrounds and the thought process on why Parsec is so interesting right now. And the project's looking for maintainers like myself, so and client libraries and providers. So please talk about it. Please help us mature out of the sandbox in the CNCF at the moment. And yeah, if feel free to fail. I mean, we're on the Slack, Docker Slack channel. There's a Parsec channel that you can join, and I'm there, Marc's there, we're all there, so you won't be lonely. And don't forget to check out the Dev Summit. This is something that I think, Marc, you mentioned earlier. There will be even more deeper dive demos for sure.
Yep. All right, that concludes our presentation. We're now ready for Q&A.
All right, you too. Thank you very much for a wonderful presentation. As we said before, we have time for Q&A. So if you have any questions, please feel free to drop them into the Q&A box. Anyone at all?
I have a question, Marc.
Go for it.
What's the next plans for Parsec?
What's the next plan? So I talked a little bit about I talked about the engagement we're having with Red Hat and the Spiffy Spire group. We've got a couple other engagements. We can't talk about all of them, but there's definitely activity happening. Come join us in the weekly calls to get basically an update on what is being worked on, right? So we discuss every week the progression and the projects that we're running. But definitely, if we go back to that slide with the architecture here, so the client libraries are being built out. So today we have Rust and C, and we're hoping to add Go as a next language to support the developers. And then there's another set of development. Again, they're all independent blocks. So the Parsec service today covers key management, sign and verify, and I think asymmetric cryptography is happening today, is being developed. There's a number of other services we want to enable. And then from a backend perspective, we have support for TPM 2.0, PKCS 11, and the embed, which you demonstrated here. There's obviously a slew of other backends that we want to enable. Now, the way that we prioritize the development, it's really based on the community engagement and what we're seeing from the developers and our partners, what they want to see in the platform, and we just keep building it out. The framework for Parsec is mature, but the development that enables all the different use cases is active, and that's where the work is taking place.
Cool.
And over the next few months, we're going to look at a more formalized released cadence where we'll tag a bunch of files and revision control, the next iterations of it.
I just saw there's a question. I might be unrelated, but I think it's totally relevant. So there are other languages we can consider. So I just shared there the Parsec client, the Go client. That's also an influx. I think it's Justin over in Docker who's been helping a lot with that. And maybe also to expand on that, are there many other services written in Rust in the IoT space? So that's an interesting one.
Okay, do we have any other questions at all?
No. Well, I mean, Marc, what do you think? Do you think there's other services written in the IoT space in Rust?
Yeah, so if you look at the most popular languages, Go seems to be the one that's on fire these days, right? Everybody wants to code in Go. Yeah, I guess it depends what they're looking for in terms of IoT. The way that I see it is the frameworks that are developed in for the cloud and for edge are making their way closer and closer to IoT, right? So if you're creating a device that's powerful enough to do all the analytics that were normally done in the cloud, you can imagine those languages and the tools that they're used to using are going to migrate to those devices naturally.
Yes, sure. Yeah, I definitely I see that there will be a vast array of languages that
Yep.
Parsec will have to support. I mean, the simple fact is that any developer can be an embedded developer. They don't have to strictly have an embedded systems background and know how to install their stuff together. This essentially the fact of the matter. We're going to become multitask, full stack, this kind of word. But I'm excited to see if we're going to have a WebAssembly client. That's another big hype at the moment.
Okay, anyone else have any questions at all?
I think maybe we should just share some dates on how to follow up and where to learn more, particularly the Dev Summit. Mark and I will be there. We talked about Parsec. We're also going to share the slides for sure. And I'll also push my kind of simple demo to a GitHub page. So please join us on Discord, join our discussions there, and also on the Docker Slack channel. We'll be definitely able to share more. And if you're watching this in recording, thanks for watching. Thanks for taking the time to watching the entire video.
Okay, well, thank you both very much for a great presentation. That will conclude today's webinar. As I said before, it will be available later today on the website. And thank you again, everyone, for your time. Have a great rest of your day.
Thanks, everybody. Bye-bye.
Bye. Ciao.